All right, so here we are. We've got a table. We don't have any idea what the table's about, but they say f is some sort of function that is twice differentiable for all real numbers. The table above for f has selected points in reference between 2 and 13. A, estimate f prime of 4. Show the work that leads to your work. Okay, so at this point, I'm hoping you're going, click, duh, got it. It's simply going to be, pick the 2 points on the opposite sides, right? So it's going to be -2 minus 4 over 5 minus 3. With that in mind, I'm going to get -6 over 2 equals -3, our slope formula. Got it? That makes sense? Now, the next one's a little tricky. It's a little weird format, and you should start to panic right away, and then you should realize, wait a second, it's not as bad as I thought. What do I mean by that? Well, let's start off. I'm going to integrate this thing, and I'm going to integrate from 2 to 13, 3 minus 5 f prime of x dx. Now, I'm integrating something with a derivative in it, and initially that sounds awful. You're like, well, I don't want any part of that. Then you realize, wait a second. That's derivative of an integral, isn't it? Second fundamental theorem. That's just the original function, is it not? So now I got to think this through a little bit. So I'm going to look at this. This thing over here becomes 3x, 2 to 13, right? Minus 5 integral. I'm going to pull the 5 out because it's just multiplied, right? So I'm allowed to do that. F prime of x from 2 to 13. In other words, what does the function do from 2 to 13? Well, from 2 to 13, the function goes from 1 to 6, right? This simply becomes 3x squared. Oh, I already did the 3x. Okay, so it becomes 39 minus 26 minus this ugly mess. And I'm going to get over here, this is just a 7. All right. Right. Nope, that's not right. That's a 13. If where people come from, where I come from. And then this is minus 25. This feels highly wrong. Oh, I get it. Okay, so right in the middle here, I have a 3 times, what? That's a 2 down there, so 3 times 2 is 6, not 26. I don't know where I got 26 from. So therefore, 6, so this becomes 33 minus 28, which is 8. I like that answer a whole lot better. Okay, use a left Riemann sum with intervals indicated to find the data to approximate from 2 to 13. Show the work that leads to your answer. Here we go. At 1, we're at 2. At 4, we're at 3. I'm just going to put them here. At 5, we're at -2. Oh, that's a little weird. Starting to panic. What the heck do we do with that? Hold on. Just relax. You're going to do the same thing you always do, right? Yeah, that's the way math works. It's lovely that way. And then at 13, I'm all the way up at 6. Okay. So using a left Riemann sum, I'm coming from the left side. So I go up. Here's my interval. But I'm going to go up the left side. Hit 2, come across. That's going to be a whopping 6, right? 2 times the bottom's 3. Here I'm going up to 3, cut across. That's going to be 3 times 1, because there's only 1 on the bottom, so that's 3. Now I go down to the -2, come across here, yeah? So that's -2, the width, the base is 3, so this goes down -2, so that's going to be -6. And then I'm going to go up here, boom, cut across here, back down. This looks like it's 5, so 5 times 3 is 15. So it looks like I'm going to get 18 for an answer. Okay, hope that's right. If it's not right, your congressman. Now, the last, yeah. So all that's fun. The last problem. We need to talk about the last problem. Last problem's a great problem. Should be on every AP test. It's not on every AP test. Probably not going to be on your AP test, but there's some darn good calculus here, so we are going to spend some time talking about it, and you're probably going to ignore it, but you have to listen because it's great. It says here, because, okay, suppose f prime of 5 equals 3, and f double prime of x is less than 0, which means concave down, right? for all values of x that close interval from 5 to 8. Use a line tangent to the graph at x equals 5 to show that f of 7 must be less than or equal to 4. Use a secant line for the graph on f from 5 to 8 to show that f of 7 has to be greater than 4 thirds. What? Whoa. Okay, I need let's relax. You know how to find a line tangent, right? So let's find the line tangent. It says let's look at the line tangent using 5, right? Because they gave us 5. At x equals 5, find the line tangent. Well, okay. Y equals mx plus b. So at 5, the derivative is 3. They told us, right? So y equals 3x plus 5 plus b. And then we know at 5 our point is 5, -2. So I put a -2 over here, put a 3 in here, put a 5 here, plus b. I get b equals -17. So my line tangent equation is 3x minus 17, right? And then it says show that the derivative, show that the value of f at 7, even though there's no value of f, you don't know what it is, has to be greater than 4. Well, how am I going to do that with a line tangent? Well, first thing you're going to notice, hopefully, is, well, what would it be at 7? So I plug a 7 in here, I'm going to get y equals 4, right? Plug a 7 here, 21 minus 17, that's 4. So the tangent line approximates tells me it's in fact 4. Now let's take a look at what we're doing here. If at 5 I'm at -2, right? And if at 8, this is 5, at 8 I'm at +3. And I do a line tangent approximation here. And it tells me at 7 I'm going to be at 4. Well, first of all, we know it's way high. Second of all, this is interesting. This thing is concave down, right? Concave down, which means coming from here and going to this point, it is going to have less slope the whole entire time. So if the tangent line tells me it's 4, we know it's going to curve this way instead, right? Because it's concave down. So therefore, it has to be an over approximation, right? That's the way it's going to work. Now, they're going to do the same thing with secant line tangent approximation. I'm going to give myself a little more room by erasing some stuff. Okay, so now secant line, you guys probably don't remember what a secant line is. This is the point in the class where you say, hey, way back when I told you what a secant line was, and I said you're going to forget when you really need to know it. This is it right here. Here we go. 5, 6, 7, 8. Here's 8. Here's 5. Here's -2. And at 8, we're at 3. So a secant line is a line going, we know the thing's curving like this, right? Because concave down. But secant line is a line directly between the 2 points. It's where we very first started calculus. We said draw a line directly between the 2 and then drew closer and closer lines to find slopes. Secant line is just a line between those 2 points. If that's the case, what is the equation for this line? Well, it's got a point at 5, -2. It's got a point at 8, 3. So therefore, it's got a slope of up 5 over 3, so 5 thirds, right, is a slope. Y equals mx plus b. I'm going to choose the point 8, 8, 3, so I put a 3 over there, would be able to put over there. Slope is 5 thirds, put an 8 here, plus b. I'm going to get 40 thirds. I'm going to make this 9 thirds on the left side by doing common denominator. This becomes 40 thirds plus b. I get -31 thirds equals b. That's all great, but that means my secant line equation would be 5 thirds x minus 31 thirds. Okay, now that I have that, I'm going to plunk in 8. Y equals 5 thirds, plunk it in 8 minus 31 thirds. And I'm going to get an answer I didn't expect. So what did I do wrong? What did I do wrong? 5 thirds, 8. No, I'm not supposed to put it again. I'm supposed to put it in 7. That's the problem. Okay. I'm getting the point we started with. So 7. So that gives me 35 35 thirds minus 31 thirds, that gives me 4 thirds. And that's what the problem stipulates. The problem says show that f of 7 has to be greater than or equal to 4 thirds. Well, let's take a look at this. If this is this point in the line and this thing is concave down, that means the point has to be above that point, doesn't it? And so you could say with certainty that because it's concave down, 4 thirds has to be an under approximation. Those last two problems you're probably not going to have to do ever in your life, but man, they're good problems because they actually ask an awful lot of calculus and an awful lot of the tools we've thus far used. And actually, in reality, when you just deal with data points, this is how they have to deal with these sorts of things. All right, got questions? Throw them at me.